Hey everyone, welcome to Huawei Cloud Tech Talk. My name is Chong Chen. I'm Senior Distinguished Engineer in Huawei Cloud. In this session, we will be deep dive into our flagship cloud-native database, TaurusDB. Let's begin. Let's do a level set before we start, which is a paradigm shift. If you look back in past 10 or 15 years, I believe everyone agree paradigm shift is very clear. People are moving away from on-prem data center to cloud. In fact, Gartner predict by 2028, over 70% of workload will be running in the cloud. And a vast majority of workload require some form of the database management capability. The workload and paradigm shift definitely impact database technology landscape. We're actually seeing a paradigm shift for cloud database too. So from initial cloud database management to cloud native database to recent serverless database. In Huawei, we actually also went through the same three phases. So we started this cloud database services 7 or 8 years ago, which is initially we just took the open source database MySQL, PostgreSQL, and also our homegrown enterprise database GaussDB, deploy in the cloud as the management services. In this deployment, a typical deployment is basically one master, one standby, and also typically a couple of replica nodes. They running within the VM and using the remote block storage as a storage services. And like MySQL, right? Using the logical replication binlog technology to do the replication between the master, replica, and the standby. So in this overall architecture, it's very suitable for the on-prem deployment. But when we're moving into cloud, we're facing a couple of challenges. Let's go through one by one, right? The first one is waste compute resource. Because you need a dedicated standby node for failover purpose. Each standby and the replica also need to replay log, construct database too. So which is consume the CPU resource on the compute node. Second one is waste storage resource. Each database instance, master, standby, and the replica will have their own data they cannot share. The next one is there's network resource contention. Since it is a remote cloud storage, all page flashing, which is coming from master, standby, and the replica, they all go through network and make network bandwidth become very scarce resource. And then the last one is since each replica has a full database data. When adding a new replica, that basically requires full data copy. Depends on really database size, right? Some large database, let's say terabyte, may take hours when you're adding a new replica. And also replication also taking time, and then this will impact the basically service availability, which is RTO, right? And also backup restore is all very slow. So this is basically the challenging. We realized it's challenging back then, right? And we started a research project in, I believe, 2016. It took more than 2 years in research, and also working with the product team to design the cloud native database new system we call TaurusDB. There's a couple of design principles, right, to drive things previously challenging. The first one is really the decouple. So we decide to decouple compute and storage, and also we decide to decouple the durability and availability. When we actually introduce this basically the log store and the page store, right? Later on in the architecture section, I'm going to cover that. Second, the principle we call NDP, which is a near data processing, because the network is a scarcity resource, right? We try to reduce the network traffic over the compute and storage, and also between the compute too. So we try to push the I/O heavy database operation into cloud storage to reduce the network overhead. And next one is we try to leverage in cloud storage reliability, which is cross AZ, right? And also availability as much as possible. So that we basically do the replication in the storage instead of on the traditional compute layer or database layer. Right? And the last one is also we're fully leveraging the modern SSD, right? The append only nature, reduce the disk wear. And also, like the most important one is actually the database ecosystem, right? Because when you're moving your application workload from on-prem to cloud, the last thing you want to do is like changing your application, right? Adopt a new system. So we consider that, and we actually make our services 100% compatible with MySQL. You can think about it as MySQL, but it's a better one. And now here's the final architecture, right? So there's a couple of key points. First, log as a database, because network is a secondary resource, right? As I speak before. And also like system need to cross AZ. So our system follow log as a database principle. So we only ship the log across the entire system, including master to storage, and from the master to replica, and so on. Second one is key design point is like our storage is a purpose built for cloud multi-tenant storage system. We use the pay-as-you-use mode, so you don't need to worry about like a traditional on-prems or even the management cloud service, the cloud database services, right? You don't have to plan how much disk space I need, right? We actually automatically help to plan for you, right? Next one is like on the storage front. We separate the database durability and also the page read availability, right, requirement. We introduce a log style and the page style as I speak before in the architecture. So this further decouple will bring a more stable performance compared with other major competitors. So we optimize the full stack from compute, storage, database kernel. So our database performance is better than traditional MySQL 7 times. This how it works has been published in the top conference, Sigma, right? So if you're interested, you can read a little bit more detail in there. Okay, so this next slide actually show the basically a bit of detail on how we deploy in the single database, right? Or in single region environment. It's actually 3 AZ deployment. We actually leveraging the storage. We support the cross AZ data reliability RPO equal to 0. And also the high availability RTO less than 10 seconds. We talk about like really the single region deployment, right? Then how about the cross region? Okay, so we're on top of single region deployment. We introduced a RegionlessDB feature, which is actually based on the physical replication technology to support the cross-region disaster recovery and also near data access. So our data replication lagging is actually less than 1 second. So in the traditional technology, it will take seconds or even minutes. So RegionlessDB, we actually right now support the 5 region deployment. As we talked about, if you remember, right, our last phase of the database involvement get into the serverless database. The serverless database is the latest paradigm shift. In Huawei Cloud TaurusDB, we offer 2 modes. One is called reserve resource mode. The other one is called serverless mode. The serverless mode is very suitable for customer dynamic application. If you have a very stable and static workload, you don't need to worry about that and go to this mode, right? However, if you have very dynamic, let's say peak and valley type of application, serverless is really like suitable for you, right? Serverless bring lots of benefit. One is really maximize resource and also reduce cost. Second one is adapting to service change, reduce the business risk. Last one is actually most important one is really we actually can automate, improve the operation. Right? You don't have to really worry about the capacity planning and the other thing. TaurusDB, right, support full stack service. So there's we have 4 different aspects, right? So from the workload detection speed, our instance load can be detected and adjust in seconds. We are still working on to further reduce this number. In terms of the unit, our resource granularity, right? The memory grown, we actually based on the 2 GB unit right now. So for the application stability, you can think about like when serverless database need to vertical grow, right? It will eventually hit a wall. So one of the challenges is when you hit a wall, where do you go, right? To solve this, we actually have a technology to actually helping on the migration. So we support application transparency, migration. It actually almost no impact to the customer application. And the last one is the scale. So right now, our service offer actually support 1 writer and 15 read replica up to 1,000 virtual CPU. So this concludes today's talk, TaurusDB Deep Dive. We hope this session will actually provide invaluable insight into our TaurusDB architecture, design principle, and unique advantage. Thanks for your attention.